In this problem, we have a trinomial. We cannot combine these terms the way they're written. You cannot combine square root of 48 with the square root of 75 for the same reason that you can't combine an x with a y. They're not like terms. So what we can do, though, is we can try to simplify each of these square root expressions first and see if we can get them so that the square roots are the same. For instance, in the square root of 48, 48 is not a perfect square. However, you could write it as square root of 16 times square root of 3. At least the 16 is a perfect square. Same thing, 75 is not a perfect square, but you can write it as square root of 25 times square root of 3. And at least the square root of 25 can be simplified. And with 80, 80 is not a perfect square, but you can write it as square root 16 times square root 5, where at least you can simplify the square root 16. So let's simplify what we can here. 8 is still 8. 16, or the square root of 16 becomes simply 4. Square root of 3 you can't simplify. Here, the square root of 25 is 5, and the square root of 3 cannot be simplified. Here, square root of 16 is 4, and square root of 5 cannot be simplified. So now we've got 8 times 4. We have 32 square roots of 3, minus 6 times 5 is 30 square roots of 3, plus 7 times 4 is 28 square roots of 5. So it's kind of like if you have two x terms and a y term. You've got two square roots of 3's and a square root of 5. At least we can put this and this together. 32x minus 30x would give you 2x. So 32 radical 3's minus 30 radical 3's would give you 2 radical 3's. The 28 square roots of 5 won't simplify any further and won't combine with the square root of 3 either. So this would be our simplified answer.